In this video, I would like to show you our first JavaFX multi-threading example, which creates a background thread to run the clock. I'm using the same steps to create and configure a new JavaFX project, and this is one I called week 13. You can find the source code for this version of the clock project in week 13.03 RunningClock subfolder of the source code zip file for this lecture. Let me show you first what this application does, and then we can go over its organization and features. It displays the running clock and shows the time in hours, minutes, and seconds. The clock can stop when you click the stop button and resume when you click again. So this is all that we have here in our user interface. So let's stop the clock and exit. First of all, I added the data publisher class from the click counter, and I modified the data publisher notify observers method to use platform run later, which takes the lambda expression which will execute on JavaFX application thread. It will asynchronously switch to the GUI thread to run this code. In general, when I see a lambda expression, it's the code which will not immediately execute, but later, when the component that stores it decides to call it. And this is very important because otherwise the information on the screen is getting updated, but exceptions may be thrown, like array out of bounds, if we do not switch to GUI thread before updating any text fields or any labels on the screen. In fact, often, despite that updates keep shown on the screen, the exceptions can freeze the user interface, making it no longer usable, like you can no longer click anything and get a response, which is really bad. What makes it even worse, it's very unpredictable when it might occur, very unpredictable and random as to when this exception might occur. Sometimes it can be very difficult to track down. If you see errors like JavaFX null pointer exceptions or array out of bounds, check every place to make sure that you're appropriately switching to graphical user interface thread in your code. And what you can do is just simply use a platform run later. In this example, we do this because the updates will be happening from the data object managed by the background thread of execution, so switching to the GUI thread here is absolutely critical to do. In summary, talking about incorrect GUI handling by non-GUI threads is only JavaFX thread can work with user interface components. Any non-GUI thread touching anything on the screen gets you in trouble, and the behavior is unpredictable. By the way, it's quite possible to get yourself to make this mistake because we often copy and paste the code and forget to wrap it in platform run later. To avoid this situation, it's very simple fix by switching to JavaFX application platform and wrapping all that updates to the screen inside the lambda expression to make sure every user interface update is done on GUI thread. The next step that I did in developing this demo project is that I added a RunningClock subclass of the data publisher, and this is an adaptation of the original RunningClock that we had in console application in the previous videos. So keep running is the clock state. It tells the clock class whether the background thread shall remain alive. So the clock continues to run as long as keep running is set to true. Notice that initially the clock isn't running, it stopped, and no background thread of execution exists. Timeout in milliseconds, the time loop goes to sleep for 1 second to make sure that clock gets updated every second. String clock here is a user-friendly format to display current time, as we identify by the parameter to the simple date format, which is hours, minutes, and seconds. The time loop method is the heart of the clock class. It has the loop that updates the current time. And notice it calls notify observers, which is now available in the superclass because RunningClock extends the data publisher parameterized by the RunningClock. So every time the clock changes, we notify the observers, and in this case, the observer is our label in the presentation tier of our application. Two more methods here is keep running and set keep running. So these are setters and getters for the Boolean keep running attribute, as this is the state of our clock. Also notice that the setter creates the new thread object and launches the thread by calling its start method. Obviously, we start the new thread only when the keep running Boolean indicator tells us that the clock should be running. And the runnable implementation is done by this lambda expression, which simply calls the time loop method inside this RunningClock data object.